If you haven't subscribed, ensure you do so. A supersonic jet traveling at Mach 3.00 at an altitude of height or of h is equal to 2.0 times 10 to the power 4 meters is directly over a person at time is equal to 0, as shown in figure P14.35. So we are going to see the diagram. Assume the average speed of sound in air is 335 meters per second over the path of the sound. A. At what time will the person encounter the shock? The shock wave due to the sound emitted at time is equal to 0. Then B. Where will the plane be when this shock wave is heard? So in our videos previously, we mentioned that unless otherwise stated, the speed of sound in air is 343 meters per second. So unless otherwise stated, meaning if they've not mentioned about the speed of sound in air, then we are supposed to use 343 meters per second. So in this case, they have mentioned the speed of sound in air, which is 335. So let's look at the diagram. So this is the diagram. So this is the plane flying at an altitude of 2.00 times 10 to the power 4 meters, which is 20,000 meters. So this is the observer here. So the plane travels, then the observer hears a boom. So let's try, we see how we are going to answer this question. So suppose an object is moving at a speed higher than the speed of the wave. Suppose that is what is happening. What is needed, or what is involved? So this is what we call an object is flying at a supersonic speed. So in this scenario, the Mach number is given by Mach number is equal to speed of the source over the speed of the wave. So speed of the source is Vs, then speed of the wave is just V. So in this scenario, we've been given the Mach number to be 3. So the speed of the source we haven't been given, then the speed of the wave we've been given to be 335 meters per second. So what do? We substitute in this equation. So when we do that, and when we make velocity of the source the subject, the formula, this is what we get. So when we multiply, we are getting the velocity of the source to be 1005 meters per second. So that's the velocity of the source. Then we can also it is also important to note that the angle between the tangent, or between the lines of the to find the angle in this case of our question, we are going to consider to say sine theta is equal to velocity of the wave over velocity of the source. So when we want to find the angle here, theta is equal to sine inverse velocity of the theta is equal to sine inverse velocity of the wave over velocity of the source. So this is what we have there. When we replace, velocity of the wave is 335 and the velocity of the source is 1005 meters per second. So this is what we get. Then when we punch that on a calculator, we are getting our angle to be 19.5 degrees. So that's our angle between those tangent lines. So using SOHCAHTOA, tan theta, so we are doing this, we are referring this to the diagrams to find, since we have found the angle to be 19.5 degrees, then we have the altitude, which is 20, we have the altitude, which is 20,000 meters, and we have the angle here, which is 19.5. So to find the distance it has traveled, we can just simply find this distance here, from here to here, this distance. So if we look at SOHCAHTOA, tangent is the one that can work for us. So we'll say tan theta is equal to opposite over adjacent. So the opposite is the one we are, so which one is the opposite? The opposite, we've said, is 20,000 meters. Then the adjacent is the one we are trying to calculate. So we will just say adjacent. So at this point, we can do the cross multiply. We do the cross multiplication, and when we do that, we find that this is what we get. So when you solve it mathematically, you get the adjacent to be 56,478.3 meters. So this is the adjacent, and this is the distance it traveled when the boom was heard. So let's also look now at the time. So since we have the distance, then we have the speed, so it's easy for us to find the time. So let's look at the time. So speed is equal to distance over time as given in the equation. So when we make time the subject, the formula, this is what we get. So the distance we have calculated to be 56,478.3 meters. Then the speed, we found that it's 1005 meters per second. So when we punch that on a calculator, we are getting the time to be 56.3 seconds. So this is the time it took to hear the boom or the shock wave, to experience the shock wave. So at this point, we have done what the question required us to do. Thank you for watching. Remember to subscribe to our YouTube channel.